So we're recording. Welcome, everyone. Sure, first assignment in, done, marked, and I think you've got your marks back. I have tried to provide feedback to all of you in your marks. And if you've got any questions, please email me. I do apologize if I've missed some of your emails, but I have had a bit of a computer malfunction, as we tend to nowadays with technology. So the preferred way of communicating is through an email, and you're more than welcome to pop me an email with any questions you may have, and I will do my best to answer them as quickly as I can, because I know that feedback is important, and I also know that learning in this online space can sometimes feel quite lonely. But the most important thing is that you ask for help, and I'm here, I'm available, so pop me an email if you have a problem. So this learning unit is learning unit 4. So we're over halfway now in our first semester. Well done for keeping up to date. This learning unit is on the perceiving mind. It's about sensation and perception, and it refers back to chapter 5 in your textbook. There's quite an emphasis on your textbook in this section. I think a lot of the material that's online refers you back to your textbook. So I'm using the textbook as my source of reference for this presentation. On the first slide, I have put up what the objectives and the outcomes are of this learning unit, and these are taken straight from your VC Learn. So they are there. And if you work through them, it shows you the points that you should know. What I've tried to do with this section for you is, because again, it's quite a long section and it's quite lengthy in terms of biology and processes. I've tried to find a way to summarize it so that hopefully by working through this, you can see it in a clear way, and it will help you understand why this section is relevant and how it can be used going forward in psychology. So those outcomes on the first page are from your learning unit on your platform. Okay, so the most important thing is to understand why we think we have to study this section. I think, Elia, they're under lecture slides, correct, online tutor slides. Sensation and perception have been around forever, back to evolution, and part of that was an evolution about people sensing fear or tasting food. So we've been equipped with senses specifically. So that's your senses are your sight, and it's your hearing, and it's your taste, and it helps us take in the world around us. And the important thing about this is it leads to how we interpret our environment, and that leads to experiences, how we experience the world. So from a psychology point of view, we are always interested in why people think the way they do and why they behave the way they do. And that information comes, a lot of it, from our senses. So that's why this section is important. So our senses connect us to the outside world, and they send messages to our brain, and our brain interprets those messages and then can perceive what is happening around us. And we are bombarded by information, all of our senses, all day, from the minute we open our eyes in the morning till we go to sleep at night. There is always something we are seeing, we are hearing, we are touching, we are tasting. And there's so much information that our brain doesn't always process all of it, but what it does process impacts on how we perceive things. Our experiences, beliefs, and culture affect also what we notice out of all of those stimuli that come channeling into our body every day. So our brain takes information and it interprets it, and then it gives us an experience. And what we experience then impacts on how we think and how we behave and how we feel. So that's why this section is important for you to look at. So it starts firstly with understanding the difference between sensation and perception. So they're two different things, okay? Sensation is where the journey starts, and it's the process by which our sensory receptions and nervous system, they receive stimuli from the environment, okay? And that is what sensation is. It's the process of seeing something, hearing something, touching something, tasting something, smelling something. That's the stimulus that comes into our bodies. And that sensory information then travels to the brain. The process of transduction is simply taking that sensory information that's coming in and transferring it into neural signals. We learned about neural pathways and how neurons work in the previous section, so you should understand that. So the stimulus comes in, it's transmitted into neural signals, which then travel through our nervous systems to our brain, where our brain makes sense of that information. And we have a lot of information coming into us all the time. So we tend to, as humans, have selective attention. So that basically means that we pay attention not to everything. It's impossible to pay attention to everything all around us all of the time. So we tend to pay more attention to those stimuli that are of a high intensity and grab our attention, because those are often stimuli that impact on how we react to a particular situation. And we also have the process of selective adaptation, which basically we hear stimuli all the time, so our response to those stimuli can change. So the example that's given to you is if a fridge motor is humming in the background. My fridge motor hums here in my kitchen, but I actually have got used to it. It's just a sound now that's a peripheral sound, and it doesn't interfere with what I'm thinking or what I'm feeling. So our body also adapts. The more we hear a stimulus, we pay less attention to it. So that's sensation, and it's the stimuli and how we actually bring the information from the environment into our system. Perception, on the other hand, that is taking all of those stimuli and the sensory information and organizing it into meaningful things. So that's where our brain works. It's where our central nervous system works. It's about information getting to the brain where it can be perceived and we can act on it. So, perception takes place sometimes, in fact always, using bottom-up processing. So that's where the brain takes all of these signals that are coming in and builds them up like building blocks from the bottom, okay, to construct a behavior or a cognition. Top-down processing is whereby your memory and your cognitive process interpret incoming sensory information. So that's very much around your past experience. It's around imposing structure from something you've already experienced. So it's like reading. The letters make up individual words. So the letters get recognized, but the actual putting the word on top of the letters, that's where the top-down processing takes place. So perception is from the bottom up. Those are all the small stimuli. And if we remember back to where we were talking about structuralism and breaking things down into the simplest building blocks, that again is what bottom-up processing is. It's the tiny building blocks that go into your brain, and your brain creates a picture. And top-down is where it assists it, because it's already got a memory of that particular stimuli. So that is the difference between sensation and perception, and that's quite important to understand. So the senses, an example of bottom-up processing is like it says in your book, and I'll just refer to your book. For example, we construct our visual reality from information about light that is sent from the eye to the brain. Okay, so it's the actual light coming in, and your brain interprets a visual image onto that. That's the top-down part of it. So the process of stimulation through transduction, where it's taking the stimuli and it's sending them through your system in neural signals to create perception. So the difference between sensation and perception. So with perception, okay, there is a science that specifically measures perception, and that's called psychophysics, which studies the relationship between stimuli and perception. So the stimuli are the physics part of it, and the perception is the psychology part of it. So that's where, for example, we spoke about a hub science. That is where medical or scientific information can be applied to psychology to look at the relationship between stimuli and perception. And within that, there's a couple of points to note. One of the concepts is called absolute threshold, which is the smallest amount of a stimulus that can be detected. So there's some nice examples there for you. So vision, your threshold is basically a candle flame 30 miles away, or a watch ticking 20 feet away, a drop of perfume in a 6-room house, a teaspoon of sugar diluted into a gallon of water, a wing of a fly on your cheek. Okay, so it's the minimum level before you actually perceive, or as you perceive that stimulus. That is your absolute threshold. The difference threshold is where you've got two different stimuli, okay, and it is the smallest detectable differences between those two stimuli. So if you look at the picture on the right, the difference threshold, it's the smallest amount of change in a stimulus you can detect. So there's some colors there on the screen, and you can see that the top block has got 2 shades of blue, and you can just percept there's a slight difference between those 2 blues, but the one below, you can see very little, if any, difference. So your difference is the smallest amount of change in a stimulus that you can actually detect. And obviously, the larger the stimulus, the larger the difference. So those concepts are important concepts when it comes to discussing, yes, correct, the mysterious black dress, blue dress, gold dress. It's interpreting difference, and we see things differently. So signal detection theory, okay, so signal detection theory is basically, it predicts how and when we detect that stimulus amongst all the other noises that are going on. So we never hear a stimulus in isolation, unless we're sitting in a room where it's silent and they say, can you hear a pin drop? But generally there are other things, our body is being bombarded by other stimulus. So signal detection theory predicts how and when we detect the presence of a faint stimulus, which is the signal, amid background noise. This theory assumes that there's no single absolute threshold, and the detection depends partly on a person's experience, motivation, and fatigue. So how we perceive something is never in isolation. There are other things happening in our experiences, how motivated we are or how tired we are, that impacts on how we detect that signal. So signal detection is a 2-step process. The first part of it is the intensity of the stimulus. So it's the belief that that actual stimulus did occur. It was not a figment of our imagination. And the second part of it is the criteria by which we make that decision. So the example that you can give is the word signal changes meaning depending on the situation. So if you've got someone who gets injured, the doctor's analysis can be measured using the signal detection theory. We've got a block there with hit, miss, false alarm, and correct rejection. So an example of a hit, that's where the perceiver's response is that the stimulus occurred and that the stimulus is actually present. So if a person pulls a muscle and the doctor correctly diagnoses the injured person, okay, that's a hit. He's got it right. Okay, the same way there could be a miss. A miss means that there was no stimulus and it was not, the person didn't even feel anything, okay? A false alarm is when, for example, the stimulus is present and the perceiver's response, the stimulus is absent, but the perceiver, the person who's interpreting it, says, no, you haven't pulled your muscle. It's a false alarm, okay? You might have hurt your knee instead. So it's just how that signal is detected around the intensity of the stimulus and the other things that are happening in your life at the same time. So that's signal detection. So in terms of the book and the way the book and the chapter is structured, it focuses on 4 different areas. It focuses on the visual, which is our eye, how we see things. It focuses on the auditory, which is how we hear things. It focuses on the sense of smell and taste, which is our chemical senses. And it also focuses on the somatosensory, which is our body position, touch, pain, and also temperature. So the book focuses in those 4 individual areas. And within each of those areas, the vision, the auditory, smell and taste, and somatosensory, each one looks at what the stimulus is for that particular sense. It looks at the biology as to how our system processes that information. It looks at the perception and cognition, that is how we perceive it and how we think about it. They look at individual and developmental differences in each of those senses, as well as sociocultural influences. So what I've done is I've tried to provide a summary for you in each of those areas to try and make sense for you as to what is in your textbook. So the visual system, the actual stimulus, this is we're talking about now what is coming in from the environment that is considered as the stimulus. So with our visual senses, what comes into our system through our eye is light, okay, or it's energy from an electromagnetic spectrum. And light moves in waves, okay, and if you picture the wavelengths going up and down, so how close together the wavelengths are, the frequency tells us what color we're perceiving, and how high or low the waves are is the amplitude, and that tells us how bright something is. So the stimulus for our visual system is light, okay, or energy, which moves as wavelengths, which is what our eye interprets. So that is the stimulus for vision. For hearing or for auditory senses, it's outside of us, there's a movement and an object sets off waves of vibration, and molecules next to each other collide, okay, and that's what creates that wave. Again, like energy is in waves, so is our auditory senses. And the amplitude of the wave, that's the height of the wave, tells us whether it's a loud or a soft sound. And the frequency, which is pitch, that's how high it is or how low it is how close together those waves are. So auditory is a collision of molecules that set off waves, and it's those sound waves that enter our ears. With our somatosensory system, which is our body position, touch, and pain, how do those senses come into our body? So it's when our body makes contact with a surface, okay? Our feeling of touch, it can be internal. We have somatosensory inside our system, actually within our organs, and we also have them in our skin as touch receptors. So it's basically when you touch something, that is where that sense comes from. So we've got vision, which is light, auditory, which is sound waves, somatosensory, which is basically touch and our body position in space. And the chemical senses, which is our smell and our taste, the sense of smell comes from molecules in the air, okay, which is olfaction. So those molecules enter our nose or our nasal passages. And our sense of taste also comes from molecules which are dissolved in saliva, and it's called gustation. So that's where our sense of smell comes. The stimulus for smell is from molecules in the air, and the stimulus for taste is for molecules that are dissolved in saliva, which then go through the process of gustation. So for each of those senses, it clearly outlines what the stimuli are that trigger those senses into the perception process. I hope that's clear. Now, the biology section is probably sort of the most complicated section, but it's actually, it's not, I'm not going to explain it because the biology section is very clear in your books. The visual section is the biggest section. It's probably got the most pieces of information to understand. So the best way to understand it is to take a diagrammatical representation and have it in front of you, and then just to follow the process that's laid out in your textbooks. So once that light stimulus enters your eye, what happens to it? And I would just in a notebook, for each one, just work through your textbook and just put it in point by point by point form. Once it's written like it is in the book, it can look very confusing, but once you lay it down, it's quite straightforward. So, for example, with the eye, which allows us to see light, we have the eye, and then we have the cornea, which is the clear surface on the front of the eye, which then directs the light. We've got the pupil, which is that little black dot in our eye. That's where the light actually goes in. And I know that you know that a pupil can be dilated or contracted or constricted. So that impacts on how much light it lets in and out. We've got our iris, which is that lovely brightly colored blue eye, green eye, brown eye, however you are. That's a muscle that surrounds the pupil, and it responds to the light in the environment. Then we've got the lens, which sits behind that, which is the main thing that we use to see. And that's where the muscles are that help us see long distance or near vision. And our retina, which is where the neurons are that process all the light. And so inside that, we've got rods and cones, and they're also responsible for seeing color. So as I'm just laying it out to you, it's literally step by step by step through the textbook. So don't get too stressed over this section. It looks quite difficult, but it's actually not that hard once you lay it out like that. So that's the biology. It's how the body actually takes a stimuli and how it actually goes from its receptor or its neuron into the brain where perception takes place. So the ear, you have the outer ear, the middle ear, and the inner ear. Your outer ear is your pinna. That's like a funnel where the sound waves come in and it channels it down into your auditory canal. So those processes are quite straightforward. So I don't want to spend a great deal of this lesson going through something that's very clearly laid out in your textbook. So we have the stimuli and we have the biology, so how it actually functions, and just take some time just to read through that and just make some simple notes for yourself as to each step that would happen in the process. So the next part of it is the perception. So it's how, when we get all that information into our brain, how do we perceive it and how do we think about it? So we've got the stimuli, we've got the biology, and now it's in the brain, and it's how we see it and think about it. So for our eyes and our visual stimulation, we interpret information from our eyes. So what do we see when we take in information? We translate it into color. So we see things in color. Okay, so there's a couple of different theories outlined under color. And one is the trichromatic theory. That's basically that all the primary colors are moved into our eye. It's red, green, and blue. Okay, and there's cones in our eyes that take in the colors, and the comparison between the cones and what information they take from it determines the color. Some people have color deficiency. We used to call it color blindness, but now it's more appropriate to call it color deficiency. So people might perceive color to be different to somebody else. I always wonder, is the purple I'm seeing on the screen the same as the purple you are seeing on the screen, and how would we ever know? So the trichromatic theory is based on the primary colors going into cones. Some people see color differently. And then the opponent process theory is another theory that talks to color vision, and it's basically saying there's color channels, and inside each color channel there's two colors that are represented, and one will always compete against the other. So that's the opponent process theory. So what they say is the trichromatic theory gives the framework, but all of our definition and our deep processing of color is from the opponent process. But all you really need to know is that perception in the eyes is about color vision. It's also about recognizing objects. So we interpret, we see things in color, we see things in shapes. So there's a mathematical pattern of lines called gratings, and it's how we interpret those gratings will help us see objects. We all then talk again, and interesting, you remember the Gestalt theories that we spoke about in the first chapter, which, if you remember Gestalt objected to structuralism and all the small pieces. That says you see things as a whole. So that means that the whole is more than all the sum of its parts, which when you think about perception is correct. It is applying a whole to a number of different inputs. So that just says, the Gestalt theory says that we're born with tendencies to recognize incoming information. So what they do with the Gestalt theory is that we have a natural ability to simplify and interpret objects or images. There's the principle where there's always a foreground and a background, and we can see that difference. Think of that picture of the vase, which can be interpreted as a face or a vase. It's how they separate the foreground and the background. There's proximity, so they also believe that the closer things are grouped together, the better that you will see the whole, or you'll see the object, which makes sense. Continuity, so smooth lines between things we see, and simplicity is the simple solution to see a perceptual problem. So within our visual senses, there is the principle of Gestalt psychology where we see the whole. And the other part of vision and about how we see things is depth. So when we see things, we see them in a three-dimensional way. We interpret a two-dimensional image and we see it in a three-dimensional way. We don't see the world as flat. We see it as depth. So that's about depth perception, how we perceive things to be near or far, and how sometimes there can be visual illusions in how we see things that changes how we see that particular depth. And that talks about monocular or binocular vision. Monocular is looking through one eye, and binocular is looking through two eyes. And if you put one hand over your eye, you sometimes see a different depth perspective than if you're looking through it through both eyes. So that is how we start to perceive the things that we see. With color, we recognize objects and we see depth. With our hearing, we hear pitch, okay? That's the frequency, how, pitch, pitch perfect, singing squeaky voice or not a squeaky voice, which is about the frequency, and that takes place in what's called the basilar membrane in our ear. And we have high frequencies and low frequencies. The loudness, okay, is the way the frequency interacts with the perception of loudness. So a normal loud volume would be the sense of, it's falling into that sense of speech. So that is a normal sensation of loudness. If I shout, then it's increasing the loudness. But your general normal range is the same as a range of speech. We also perceive where the sound is coming from. So is the sound coming from the left of us or the right of us, above us or below us? And we've got two ears, the left and the right ear. And so we know if something's coming from the right, it would go to that ear first. Okay, so the localization of sound, where is the sound coming from, helps us interpret whether we need to turn left or whether we need to turn right to find the sound. But also, you find that senses never act in isolation. So when you have perception, you will be having a visual input as well that will help you make sense of that sound. And auditory groupings is sounds from one location are grouped and we assume they're from the same source. Okay, so when a sound also starts and when it stops. So auditory grouping. So within our hearing, we have pitch, helps us understand the sound, how loud it is, where it's coming from, and if there's a number of sounds coming from the same place. With our somatosensory perception, that talks to our body position. Okay, so how is our body positioned? That also comes from within the ear. I think if you know you've got a cold and your ears are blocked, your sense of balance goes off a little bit. That's why it's called the vestibular system, and it's part of your middle ear. And And again, your body position is linked with visual processing, where you actually see yourself at that point in time. Our perception through touch. Obviously, touch can tell us the size of something. It can tell us texture. It can tell us consistency and shape. And also, it's from our visual environment, we have a perception, then we touch it and we feel it, and it can confirm how we expect to feel something. So touch is an important way that perceptions are processed. And also, don't forget, touch is a role in communication, hugging people, babies, a sense of touch. So touch also speaks to communication as well. And pain. Pain is an important part of the somatosensory system. It reminds us, it's there for a reason, it reminds us when we're injured. And it allows us to assess a situation before processing it, and it also allows body time to heal. And pain is quite an actively constructed experience, and it involves expectations and past experiences. And there's a good section in your textbook on pain and how pain is experienced, how it travels to the brain. So pay attention to that part of your textbook. It also talks about the gate theory, where pain messages are coming into our body, but pain messages can be modified by other senses. So, for example, your touch. So if you bang your elbow, it's painful, but if you rub your elbow at the same time to make it feel better, your brain is now getting the pain message, but it's also getting the touch message. And so the touch message will dilute the pain message. It's burn your finger, put it under a tap, suddenly the change in temperature in the cold water will reduce the pain message that's going to your brain. So that's how the gate theory works in your perception of pain. And the chemicals senses, your smell and taste, how are they perceived and thought about? So the book says there's 3 interesting perceptual themes. Is that think about food. This is always the picture of the pizza, makes you understand that this is about smell and taste, that we can easily identify complex stimuli combining different molecules. So for example, coffee or an aroma, it's not just one smell. There's often complex stimuli in that, and they combine and we get a smell. It's never a single stimuli. And we as humans can detect small differences amongst similar smells and tastes. So we have got very selective taste. And so small differences, you could eat something, a piece of meat, and you go, oh, that's off. And another piece of meat, that's not. So we can detect small differences amongst stimuli. Yes, there is a page for Gates theory. I will tell you the page now. Page for Gates theory is, sorry, I'm moving the textbook around for you. Pain is 181 and 182 is where you'll find the Gates theory. 182 is specifically the Gates theory. And experience often shapes perception. So the experience we have with the taste, we might have tasted something in the past and we didn't like it. So how we experience that sensation of taste could be linked to something we've experienced in the past. And that's an example of top-down processing. So we already have something in our mind that is going to impact how we perceive that particular taste. So you might have tried sushi, for example, once and gone, oh, I really don't like this, and someone offers you again, then the experience that you had originally of not liking it will change or impact on how you taste something. So the way chemical senses work is they interact to provide a perception of flavor. So that's how perception and cognition takes place within the senses. So now we've got the stimuli, we've got the biology, and we've got, once the biology moves through to the brain, we've got how our perceptions and cognitions are shaped within each of these different senses. So the other part of it is developmental and individual differences. So again, within each of these senses, how they develop is different, and there are differences between individuals. So it's just important to recognize that. So if you look at our sight or our vision and think of little babies, okay, babies are born, and you'll do some of this, or you'll do quite a lot more of it once we get to developmental psychology of children, and you'll see infants have gazing patterns. So pretty much when a baby is born, within a few days, their eyes start to focus on things. So they have gazing patterns, and it has been shown that they see what adults see, but with less detail. And babies prefer high contrast objects. So when you buy a baby a toy, it could be big and red and blue. And so that is what babies see, is they see larger high contrast objects. And development in vision happens quite rapidly. And as you know, changes occur when we get older. We become short-sighted or far-sighted, and our lenses change. We might need to wear glasses if we're far-sighted or short-sighted. If you walk into the cinema and it's dark and then you walk outside and it's bright, our eyes, as we get older, they don't adjust as quickly. So our vision develops from when we're born right the way through to when we get older. And obviously how you see things impacts on how you think and how you behave. So if somebody could, for example, could see and then suddenly their vision is impaired in any way, there is going to be an impact on how they think and behave. And as psychologists, it's important we have an understanding that when we're speaking to a patient, some of these issues could actually be causing the behavior. And so, again, individuals can differ. We've already spoken about color deficiency. Some individuals can be colorblind, and some individuals don't see as well as others from a young age, and they have to wear glasses. So within vision, there is a developmental change in the sense over the years, and individuals can experience things differently. With hearing or audition, again, it begins at birth, okay, and develops quite rapidly. And small babies start to recognize voices, and if you give a little baby a fright, you can see that they get a fright, and so they have a startle reaction. And so as we get older, we tend to lose our, well, hopefully we don't tend to, but some people do lose their hearing. And generally when hearing loss starts, it starts with people losing the ability to hear those higher frequencies. Individuals, in terms of being different, experience difference in pitch. And I think an example of that is singing. And not all of us can hear pitch, not all of us can sing properly. So those of us who are tuneless and can't sing, we're very different to somebody who can. So there is a difference in how we hear things between individuals. With your somatosensory senses, basically those senses are there from when you are born. And children are born with sort of somatosensory maps in their body, which develop quite rapidly. And we know that babies can feel pain, but also they have no memory of it. So I don't know if you remember when you were 6 weeks old and got your first set of injections, you can't remember that pain, but you did cry at the time, it was sore. So babies can feel pain, and pain is often negated by other physiological states. So if you are hungry, or a baby's hungry and it's crying, that physiological hunger might change how the pain of hunger is experienced. So as we get older, our senses remain pretty much intact, but we are born with those senses. And with smell and taste, newborns differentiate between tastes. Okay, when you put something in a new baby's mouth for the first time and they pull a face because it might be a sour worm, or it might be, well, not a new baby, but you understand that that taste is there. Okay, and our taste bud numbers decrease as we get older. Our taste buds actually do die and regrow every 4 to 6 weeks. Our taste buds are replaced, and it's the same with olfactory senses. Those little receptors in our nose die off and are replaced, but as we get older, they do decrease, and we get a reduced sensitivity to taste and a reduced sensitivity to smell. So tastes are there from birth until the end of life, but they do reduce as you get older. And again, how individuals experience those senses is also different. They say that females are more sensitive to smell than males. So we each are different as to how we smell things. And again, a disturbance in the senses correlates with several psychological disorders. So, for example, if you've got someone who's been in a war and there was a car bomb and it was the smell of petrol, then that smell of petrol can trigger a psychological disorder. And sense of smell or a memory around smell is often a trigger in a psychological disturbance, especially when you're talking about things like post-traumatic stress disorder. So that is how those senses develop, okay, and it's also the individual differences in the senses. The final part in each of the sections is the socio-cultural influences. So again, as much as we have individual differences, there can be differences across cultures. So within vision, there have been shown to be Eastern and Western differences in how people see things. And for example, from an Eastern perspective, is Eastern cultures tend to see things more holistically. Okay, they have a more collectivist culture as a group. So that would impact on how they perceive a visual stimulus. Whereas a Western culture processes information more analytically and focuses on specific objects and categories. So that could be due to their individualistic culture. So there can be a difference between culture around perception, how the brain provides behavior and thinking to do with that stimulus that can have a cultural implication. And there's also issues like social norms. In some cultures, you don't make eye contact. And again, there could be influences of genetics drift, or biology that impacts different cultures as to how they perceive things. So there's a socio-cultural influence. The auditory influence, how we hear things. Again, culture can provide a framework for how we interpret stimuli. So an example could be there was a sound that was given and no instruction was given. People were asked to identify what the sound was, and people said it's birds. But when people were told that it is speech, then they identified language elements in it. So how people perceive a specific sound can also be related to the environment that they've grown up in or the culture they've grown up in. And what's interesting as well is perception can form its own culture. So where we've got people who are hearing impaired, there's now a culture that's been created around a deaf culture or a hearing impaired culture where they have their own set of languages, attitudes, and norms. So again, culture can have a very big impact on how we hear and how that perception is used. And the pain, body position, somatosensory senses, the sense of pain is dramatically influenced by culture. So the example is preparedness for childbirth. So if people go to childbirth classes and understand the process of childbirth and watch videos, which we do in a Western culture, it generally prepares people for childbirth. There'll be a reduced pain experience. Whereas where people go into childbirth, where they haven't had that educational context, they find that the pain experience is more. So that also culturally has an impact on how we interpret pain. The tolerance of pain levels between athletes and non-athletes. You have an athletic community. Remember, culture doesn't necessarily have to be about geographic location. It could be an athletic community or a group of people. And a sense of control may reduce anxiety and the need for pain medication and self-administration. So if you are in hospital on a trip, on a morphine drip, and you can administer your own pain, that can reduce anxiety, okay? Whereas if you are waiting for a nurse or a doctor to come and give you an injection, you become more anxious. So those again are influences about how we can perceive different sensations. And with our smell and taste perceptions, obviously, manipulation of scent for many reasons. Scent is never the same. We manufacture scents for religious reasons, medicinal reasons, or personal reasons. You put an air freshener in your car because you don't like the smell, or you want the smell of a new car. There could be a specific incense or some sort of religious smell that's required. So manipulating scents for many reasons often has a socio-cultural base to it. And the experiences that we have with food plays a role in how we taste it and how we perceive taste. So you might travel to a different country where the food is unfamiliar to you, and you might go, oh, this really isn't nice. But somebody who is living in that world, and that is their everyday food, they have no problem with how it tastes. So sociocultural influence has an impact on how we taste things, and again, that's experience. And when we look at little babies, they tend to have a predisposition to like foods that are available in their environment that are safe. Often a child will pick something up, put it in its mouth, and realize that it shouldn't be eating that because it's not safe. So again, where evolution has played a role in that over the years as to what has been safe to eat or not safe to eat. And from culture to culture, things are different in each culture around what people can eat or not eat. So that is the social cultural influences. So therefore, I hope that I've managed to simplify this section of the textbook for you. Just break it down into those headings like I've done. Under the biology section, just put some points and make it an easy diagram to understand. And so that should give you a good framework to work with in this. So I don't know if anybody's got any questions. You have got an ask task in this section. It's around pain. Some of you, I have seen it come in, and there's people who have submitted have got a really good understanding. And when I choose the ask task, I try and choose them so that, or put them into the section so that they are preparing you for something. So the ask tasks have an important function in helping you understand specific aspects of information, so that when it comes to future assignments or exams, we've already done a lot of the work. Okay, so I don't know if anyone's got any more questions on that section. I see Petro put a question there. Okay, Petra, I did see you sent me an email, so can I reply to your email? That's one that I haven't got to. In terms of resubmission, you, just so everybody is aware, I'm only allowed to mark the last submission that came in just before the due date and the due time. Anybody who submitted after that, I'm not allowed to mark. So if for any reason somebody needed to resubmit, they had to apply through the student hub with reasons as to why they needed to resubmit. So where you have done an assignment and you want to work on that assignment, unfortunately, I can't take assignments after the due date unless I have got approval to mark that assignment. So I will pop you an email, Petra, and thank you for actually taking the time to relook at your assignment. So that is the end of that. Guys, just carry on with your next section, carry on with your ICE tasks. ICE task 3, we're on section 4, so there'll be the 4th ICE task in Learning Unit 4. So if you are up to date with your work and keeping on top of your ICE task, you should have just submitted the 4th ICE task. So just go back through your sections and pick them up. ICE tasks are important. They count to 10% of your CAS mark. So just have a look and see they are clearly marked. We haven't put one yet into the next learning unit, but Erin, the ICE tasks are there. If you can't find them, just send me an email and I'll just direct you to the right place. I think in this learning unit, it was were only 2 tasks, I think, and it was the last task on pain that was the ICE task. Okay, I will double check, and you have to submit 4 ICE tasks. Okay, that is the compulsory number for you to have ICE tasks included in your CAS. There will be 6 ICE tasks, but compulsory is 4. But the reason we have those ICE tasks is it's for integrated curriculum engagement. So it helps you actually understand the work. You can submit, I would suggest you submit all the ICE tasks, okay? But 4 of them have to be submitted. So when it gets to the end and you've only done 4, that's not a problem, but my suggestion is that you do all of them. Any due date soon? I think ICE tasks have to be in by the end of May. So we've done, this should be the 4th one in this module that will be coming in. We'll pop another one in the 5th module, and then we should get one in the 6th module, but we'll definitely have 5 that you can work towards. And I think that's the ICE task date, and then there's the next assignment, which is due, I think, is it early June? It should be there in your documents, and before that there will be the National Student Support Session, which will help you with the submission. Thanks, Sheldon. 12th of June. So the week before that, on the Friday, is the National Support Session, where you will get help in your assignment, but you can start working towards it. For those of you who didn't do so well, you really need to put a lot of effort into this assignment and don't leave it till the last minute. My name is Jeff. Hi, my name is Jeff. I will have a look. It should be Yuchi, I'll double check the dates. I think I haven't got my calendar in front of me. I know it's somewhere around the 12th or the 15th. It'll be on the calendar. Jamie, the 15th. Sorry, Sheldon, you were wrong on that one. But the ICE tasks, I think, are there because I've had submissions on the ICE tasks. But if you can't see them, just pop me an email and I will point you in the right direction. Okay, everybody, thank you. I'm going to start recording this session now, and I will upload it. I hope it's helped you. I will see you again in 2 weeks' time, where we will cover the Learning Unit 5. So you've done a lot of work. Still a lot of work to do, but you're reaching the top of the curve. So well done, everybody, and I will see you all in 2 weeks' time. But please, you've got my email address. If you need me for anything, let me know. I'm going to stop recording, and please leave via the appropriate door. Thank you. Thanks, guys. Bye.